In this lesson, we're going to look at the 9 times tables. First of all, we're going to start by using a split strategy similar to ones we've looked at before. So let's do that now. We know that 9 is the same as 10 minus 1. So when it comes to multiplication, we can think of 9 groups as 10 groups minus 1 group. Let's look at that with an example. Here is an Easter basket that holds 3 Easter eggs. If each basket holds 3 Easter eggs, how many eggs will there be in 9 baskets? Of course, I could count up by 3's 9 times, just like with any other multiplication table, but let's look at how to use this split strategy. Remember, there are 9 groups of 3 here, so we can think of this as a multiplication number sentence as 9 times 3. So let's pretend now that there is an extra basket. How many baskets are there now? There's 10. Again, we can count up in 3's or 10's, or you may already know from looking at your 10 or 3 times tables that 10 times 3 is 30. But we want to know how many eggs are in 9 baskets, so that means we need to get rid of a group. So now we can think of this as 10 groups minus 1 group. So we can say that 9 times 3 is the same as 30 minus 3. The 30 was 10 groups minus 3 in the 1 group that we took away. So now we know that 9 times 3 is 27. Once you get confident in this strategy, you can actually do it without the pictures. Let's look how. What is 6 times 9? So again, we can think of this as 10 groups of 6 minus 1 group of 6. So we can work it out as 6 times 10 and subtract a group of 6. To write this mathematically, we'd write 6 times 10 minus 6 because we're taking away that extra group. And when we work that out, we get 60 minus 6. We've just solved that 6 times 10 to start with. Then when we calculate that, that equals 54. So this is a really good strategy to use while you're learning your 9 times tables because we can use it for every question in the 9 times tables. So 1 times 9 we could think of as 1 times 10, 10 minus 1. Because we're minusing a group, which equals 9. 2 times 9 we can think of as 2 times 10, 20, minus 2 times 1, 2, which equals 18. 3 times 9 would be 30 minus 3, which equals 27. And that pattern keeps going all the way through for your 9 times tables. Let's just pause for a minute now and have a look at some really cool patterns that you can see in your 9 times tables, up until 9 times 10. First of all, I've just written out the answers to the 9 times tables here and split them halfway through. What do you notice about the numbers above the line and the numbers below the blue line? Well, if you can see, it's like the digits in the numbers are flipping. So if we look at 45 just above the blue line, if we flip those digits around, they would become 54 just below the blue line. The same thing happens with 36. Flip those digits around and what do you get? 63. Pretty cool, huh? But that's not it. What do you notice now about the digits in the units column and the digits in the tens column? Let me add in a place value table for you. Can you see how the digits in the units column go down by 1 each time? Starting at the top, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. The opposite happens in the tens column. We start with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But that's not even it then. What do you notice if you add the digits in one of the answers? For example, let's have a look at 7 and 2. If we added those numbers together, they equal 9. Let's have a look at another one. 1 plus 8 equals 9. And that's true for any number that's a multiple of 9, no matter how big it is. When you add the digits up until you get to a one-digit number, they equal 9. So let's just finish off our pattern now of the 9 times tables. We can see we get 11 times 9 equals 99 and 12 times 9 equals 108. So again, we can still use that split strategy going through. Now you may be a bit confused looking at 11 times 9 and think 9 plus 9 doesn't equal 9. But remember, we need to get it back to a one-digit number. So if we take 99, we would say 9 plus 9 equals 18, but 18 is a two-digit number. So then we need to add those again. 1 plus 8 still equals 9. So the rule still holds up. So I think the 9 times tables are actually the coolest times tables because there's so many patterns and so many tricks you can use to help you learn them. So let's have some more fun exploring them now.